Here we're going to look at properties of exponents. First one is if we have two powers with the same base multiplied, then we end up adding the powers. So an arithmetic example. If you had 2 to the third times 2 to the fourth, well, 2 to the third means you have 3 2's multiplied. 2 to the fourth means you have 4 2's multiplied. Altogether, how many 2's are being multiplied? Well, there's 7 of them. 3 plus 4 gives us that 7. So we don't have to write all of them out all the time. That gets a little tedious. Instead, we just need to remember the rule. We multiply things with the same base. This says there's 7 w's multiplied. This says there's 9 w's multiplied. Altogether, how many w's are being multiplied? It would be 16 in this case. Next rule. If you have two things multiplied and they're raised to a power, then you get to distribute the power through. Let's take a look at y with some arithmetic. So here the exponent is to the parentheses, so I have to write the parentheses and multiply twice. There happens to be a 2 times 3 in the parentheses. Well, multiplication's nice. I can multiply in any order I want, so I could consider this 2 times 2 times 3 times 3. It would be 2 squared times 3 squared, showing that that power gets distributed to each piece inside the multiplication. Now this only works on multiplication and division. It doesn't work with addition or subtraction. So if that was a plus in there, we're out of luck. Try something else. So this is a shortcut rule that only works for multiplication. So here I have 4x, which is really 4 times x, and so both of these get cubed. So this is going to be 4 cubed times x cubed. We could clean up that 4 cubed. 4 times 4 is 16, and then 16 times 4 would be 40 and 24, or 64. So I could call this 64 x cubed. Here, I have a slightly different version. I have a power to another power, and the rule there is you multiply them. So let's look at y with an example. So again, this 2 on the outside says write the base twice and multiply. Well, my base is the parentheses. There happens to be a 2 cubed inside. Here, we can use a rule we learned earlier that says if you multiply two things with the same base, you get to add the powers. That would be 2 to the 6th. And note that 2 times 3 is 6, so that's that product. So power to a power means multiply the powers. If you multiply things with the same base, you add the powers. For this one down here, I can just notice that I have a power to a power, so I can multiply the powers. 7 times 9 is 63. So that should be equal to x to the 63rd power. Now, related to that second rule we did, and the third rule we just did, we're going to throw that all together. So I have some multiplications in here. The power on the outside gets distributed through. Now the first part's pretty easy. I'm going to have a 3 to the 3rd power times x to the 5th to the 3rd. Well, that's a power to a power. 5 times 3 is 15, so that's going to be x to the 15th. And oops, that should have been a y there. And then I'm going to have a y to the 9th to the 3rd. Power to a power is multiplied, so that's going to be y to the 27th. And 3 to the 3rd is not too bad. 3 squared is 9. 9 times 3 is 27. So I could rewrite this top expression as 27, x to the 15th, y to the 27th. Now, this second rule right here, the first rule, sorry, has a division counterpart. So let's take a look at that. So if you have two powers that you're dividing and they have the same base, you can subtract the powers. So we can look at y here. So there are 5 2's in the top. Struggling. Let's try again. And then I have 3 2's multiplied in the bottom. And a number divided by itself is 1. So there's a 1, there's a 1, there's a 1. 1 times 1 times 1 is 1. So So that just leaves us 2 times 2, or 2 squared. Notice that 5 minus 3 is that power 2 right there. Now, let's apply that to a slightly more complicated situation down here. This is really 6 times x to the times x to the third. So I'm going to view that as 6 over 2 times x to the fifth over x to the third. Right? Because when you multiply fractions, you just multiply the numerator, takes me back here, multiply the denominators, takes me back there. So I just kind of unmultiplied these guys. Now that's going to let me simplify it easier to 6 to 3. And then the rule up here says if you have 2 powers with the same base, you write down the base and then subtract the powers. 5 minus 3 is going to be 2. So this expression can be more simply written as 3x squared. So there's some polynomial rules. Hope this helped. Take care.